lesson 6.8, and then it's about L'Hopital rule. First of all, when do we use it? We mainly use it when the limit as x approaches a of f of x over g of x. That's the main common thing that we'll see when it's two functions, one on the top and one on the bottom. And most of the times you use L'Hopital's rule when f of x equals 0 and g of x equals 0. So it'd be a 0 over 0. And also use it when you can also use it when the limit of x approaches a of f of x over g of x goes to infinity over infinity. That's when you will use L'Hopital's rule, and there's a theorem which is when the limit of f of x over g of x, well, as the limit approaches x goes to a, is equal to the limit of x as it approaches a of f prime of x over g prime of x. And that's when, basically that's when you'll use that. And to begin with, the theorem, I'll talk about the theorem, my bad. Theorem, L'Hopital's is, suppose f of x and g of x, or it could be any number, not just f of x or g of x. You can just put it as f and g. They are differentiable. They have to be differentiable. Differentiable. And also, g prime of x can't equal 0. So that's basically the introduction of what L'Hopital rule is. And now I'm gonna show you two brief examples. Well, also another indeterminate forms that will occur will be, these are other indeterminate forms, which would be 0 times infinity. That's one of them. Another one could be infinity minus infinity. That's another one that's another indeterminate form. These two are indeterminate forms, so as well with these. And another one would be 0 over 0. And then another one would be infinity over 0. And then lastly can be 1 over infinity. Those are other indeterminate forms. And then another common rule that you should be familiar with when using your limits in L'Hopital's rule would be this one. The limit as x goes to a or infinity, anything, of f of g of x is equal to, you can put the f on the outside, and then it can be the limit as x goes to a of g of x. It can be written like that. On to now problems, these two problems. So let's see, get this out. So the first problem is compute the limit as x goes to 0 of 5 over the natural log of ln of 1 plus x minus 5 over x. So let's do it. Number 1. So the limit as x goes to 0 of 5 over ln of 1 plus x minus 5 over x. Well, to begin with, as it goes to 0, it'd be, a 0 on the bottom, and then it'd be 0 on the bottom. So that can't happen. That doesn't make sense. That'd be undefined for me, what I'd say. And so in order to make that, to fix that error, you set them, I would go common denominators. So you multiply the 5x on that side, so it'd be 5x minus, cross multiply there, so it'd be 5 times ln of 1 plus x. And since we multiplied those across, this can become 1. So it can become ln of 1 plus x. Don't forget your limit as well. So the limit as x approaches 0. So you plug in 0 right there. It'd be 5 times 0, which is 0. ln of 1, recall, ln of 1 is equal to 0. So it'd be 0. 0 times that is 0, so it'd be 0 over 0. And remember what I said, that's an indeterminate form. So, you know it, L'Hopital's. So the limit as x, well, put L'Hopital's to show that I'm doing that, goes to 0 of 5 minus, and then the derivative, so it'd be 5 over, the derivative of ln of 1 over 1 plus x is just 1 plus x, and then the 5 goes on the top. So recall the ln of x of d of the derivative would equal 1 over x. So that's why I got that. And then this is the product rule. So it's two of them multiplying together. So the derivative first, which is just 1 times ln of 1 plus x plus, just x, and then the derivative of that would be 1 over, which is just like that, of plus x. So if you put in 0, you get 0, and then 0, and then this is just, it doesn't go right, honestly. So again, you have to do L'Hopital's rule. So of the limit as x approaches 0, and then this becomes 0, and then remember you can write this as over 1, so then you move it to the top, so it becomes negative over, and then the derivative of that goes down, so it'd be minus 5, and then you have to subtract 2, so it'd be the power of negative 2, so then you have to move it down, so it'd be 1 plus x over 2, which is squared. And since it's negative right here, they cancel, so then it becomes a positive. But we'll talk about that in a bit. Figure that one out. So the derivative of ln of that, which would be 1 plus x. And then this is the quotient rule. So remember, low d high, high d low over low squared. So low, which is 1 plus x. And then low d high, so the derivative of x, which is just 1, minus high, which is just x, d low, the derivative of that is just 1, and then over low squared. So this is the low, so it'd be 1 plus x squared. So then when you simplify it more, so it'd be the limit of x approaches 0, goes to 0, and then that becomes a positive, so it'd be 5 over 1 plus x squared over 1 over 1 plus x plus, and then it'd be 1 plus x minus x all over 1 plus x squared. So then you put 0 into that, so it'd be 5 over 1 plus. So that'd equal 0 squared over 1 plus 0 plus 1 plus 0 minus 0 over 1 plus 0 squared. And then when you simplify that down, so it'd equal 5 over 1 would be just 5 over 1 plus that, 1 over, which is just 1, plus, and then this is just 1, 1 squared is just 1, so then that would go, I guess, 1 over, and then 0, and then it'd be 1, so it'd be plus 1. So at the end, it'd be 5 over 1 plus 1 is 2, and then that's your answer. And now on to problem number 2. True or false? Is this true or false? So let's try it out. So is the limit as x, okay, so is the limit as x goes to infinity of 3 over x at 5x equals infinity true or false? Question mark. So to begin with, recall back or old, a of x is equal to e of ln of a of x. And so we can rearrange this into the limit as x goes to infinity of e of 5x ln, well, I put the of 3 over x. So I put, from the power rule, I moved the 5x down, so it'd be like that. And so remember, recall from our other previous notes what I just said. You can rearrange these things. And so, I mean, as x goes into infinity, you basically get, right here when it goes to infinity, be 0, ln of 0 be 1, and then, so it'd be basically e over infinity, which is equal to infinity, which is true. But, you know, if you don't understand that right away, we can break it down into smaller things. So you could break it down to, remember from recall, so you can move the e from here, and it can be the limit as x goes to infinity of 5x ln of 3 over x. And so you can move the 5 out, so it'd be e of 5 limit of x goes to infinity of x ln of 3 over x. And so after that, you can do 1 over x, so you can rearrange it as e to the 5 as the limit goes to infinity as x goes to that, it'd be ln of 3 over x over 1 over x. And from our rules, you can split this as well. So it'd be, continue here, the limit, let's start from here. The limit as x goes to infinity of ln of 3. And then since it's a division, it'd be minus ln over 1x. So let me track back and recall this theorem. This theorem, like I said over here, this theorem is on 6.4, on section 6.4 if you don't believe me, and this one would be on section 6.2. So the theorem is, you know, the ln of y over x is equal to ln of y minus ln of x. So that's how I got there. And then simplify L'Hopital's rule. And so then I get, you know, derivative of that would be negative 1 over x. Divide that by, and then the derivative of that would be negative 1 over x squared. And so that equals x. So don't forget everything else of the limit as the limit of 5x of x goes to infinity of x equals infinity. And so that's how I got e to the infinity, and e to the infinity equals infinity. And that's how I got true. So the answer is true. But yeah, that's how you do it. And that's the intro. That's the lesson of 6.8, L'Hopital's rule. Thank you.